Hello, and welcome back to the fourth installment of our tutorial on using Nanolyzer to analyze Nanopore data. So we're picking up again where we left off with our corrected event fits. And in this video, we're going to go through some of the visualization and post-processing you can do using this tool. So typically where you'll start once you're satisfied with your fits and everything is to go over to the statistics tab. And here you have a number of plot types you can choose from. We'll get to segmenting data sets in a future video. And there's a whole bunch of metadata that is acquired for every event fitted. So there are lots of different metadata here, and the detailed explanation of what each one of them is, if it's not self-explanatory, can be found on the blog, which we'll link to in the video description. But essentially, there are two types of metadata. And they're distinguished by whether or not the word sublevel precedes it. So any metadata that doesn't have sublevel in front of it is a single number per event. So the dwell time, for example, is the full length of time that event spends in the pore. Maximum blockage is the deepest fitted level in that pore, etc. Whereas anything that refers to sublevel has multiple numbers per pore or per event. So an event that has 2 or 3 sublevels in it will have 2 or 3 entries in these metadata columns. And I'll show you what I mean in a second. So let's start off simple, plotting the log of the duration against the maximum blockage as a 2D histogram or a heat map. And we update our plot. And so we can see here, there's 2 populations, and this is exactly what you'd expect for double-stranded DNA. You have unfolded DNA translocation and you have folded DNA translocation. And it seems like for this 4 kilobase pair DNA dataset, most of the events have at least some folding to them, which is exactly what you'd expect. And in this plot, because we're using metadata that doesn't have the word sublevel in it, every event contributes exactly 1 point to this plot. We can also look at this as a 2D scatter plot if you prefer that style of visualization. We can also look at 1D histograms. In this case, we're just looking at the dwell times. And we can play with the number of bins being used. Plot. Leave this at 0. It will simply automate the number of bins being found. But let's continue looking at our 2D scatter plot for now. If instead of a single entry column, I look at a sublevel column. So here we're looking at max blockage. What if instead I look at the sublevel blockage? Update our plot. We'll see that there are now more data points available on here. And this is because instead of looking at just the maximum blockage, we're looking at every blockage. And so an event that has 5 blockages or 5 sublevels to it is now contributing 5 points to this plot. So be careful if you have a data set that has a small subset of events that have a huge number of levels, they can really dominate these plots, which is just something to keep in mind when you're going through visualizing. We also have the option to do 3D scatter plots. So we can break this out by the number of levels. And we can see that we have one event that has 7 levels, and you can see it contributing 7 points to this plot. But the vast majority of events have 3 levels or 4 levels. And here the baseline before and after the event both count as a level. So a single step event, which is just baseline blockage baseline, will have 3 sublevels as Nanolyzer accounts for these things. But playing with these, we can also look at, instead of the total dwell time, we can look at the sublevel duration, for example, against the sublevel blockage. And here we see now that we can really start to split this up and look in very granular detail at some of the internal structure of these events, where we have some events falling into the 10 microsecond, remember this is log scale, the 10 microsecond range, all the way up to about the 150 microsecond range. So as I said before, there's a link in the video description below, which goes into detail about what every single one of these metadata columns actually means. I encourage you to just play with this. You're not going to break anything. If you are satisfied with the plot, if you like the plot you're looking at, there are a number of ways you can save it. You can either save the image, which just takes the image as you see it on the screen and saves it as a PNG file. You can also export the data, which will prompt you to pick a download location, and it will save the raw data that goes into generating this plot as a CSV file that you can then load into your favorite plotting software for post-processing for making a figure for a paper, for example. And there are also ways to save the entire data set that goes into it, which we'll get into in a future video about data filtering and database management. So for the time being, play around with all of the metadata here. Strongly encourage you to just explore what can be done with these plots to get a sense of what's available. And in the next video, we'll get into use of the database management tools to start segmenting our data set into interesting subsets.